All right, guys. So here's the deal. I'm not going to convert oxygen into carbon dioxide if I don't have to. So if you got questions or clarifications, bring them. If several minutes go by of me searching for memes on my phone, we're going to end it. So we'll discuss as much as you guys want to. Key thing is your exam is Wednesday, 8:30. Okay, set 2 alarms. Do not be late. Be accountable. I'm going to give you an extra 5 minutes, so it'll go from 8:30 to 9:25, and it's going to be on Moodle. Straightforward questions, because I'm not going to be there to clarify. So it's going to be functions of muscles, advantages of levers, all the stuff we talked about, Newton, accelerations and velocities, definitions mostly. So if y'all want to talk about something, let's get it. I'm going to hunt for memes. Yeah, okay, Kelly. So why don't you, so I'm kind of confined here. Why don't you give me the numbers, the specific numbers, and I'll be happy to work one out for you. But if you recall, I'm not going to ask you to solve anything. We solve them on our own time to show you the concepts of what I'm trying to teach you. And that is forces and quadrants show you things like y is greater than x is greater than y is positive, x is negative, like that kind of stuff, right? So, so let me give you an example of what you're going to have to know. 500-pound force, so I'm going to write down my given 500 lbs is applied at an angle of 20 degrees from the horizon, okay? Next, I'm going to write down my Cartesian plane, positive x, positive y, negative y. And 20 degrees, I can eyeball it. I mean, I know what 0 is, I know what 90 is, and 45 is here, so 20's got to be less than 45, right? Okay, so 20 degrees, my, forgive my, I'm writing on wood. So, okay, so, all right, so here's the gist. Now, what do I know? If this is 500 lbs and it's at a 20-degree angle from the horizon, I know that the x component of that 500 has got to be greater than my y component. In addition, I know that my x has to be positive and my y has to be positive. In addition, I know that my y component plus my x component is going to be greater than my resultant component. That's what you're going to just need to know for the test. Once you have a resultant, something you can measure, and you have the quadrant, you know direction, and you know who's going to be greater than who. And that's the gist. Now, if you wanted to solve it to basically to show you that what I'm telling you is true, we could solve it to show. That's why we solved it, because I was like, well, don't just take my word for it. Let's solve it out like you guys have been introduced to in physics 207 and math 210 to solve it, to show you what I'm trying to get you to see is true. So so it'd be the sine of 20 degrees is directly proportional to the opposite side. In this case, that's my y component over my hypotenuse, sine 20. So I taught you guys the trick on how to get, you got to unlock your, okay. So I'm going to go 20 sine, that gives me a percentage. Then I'm going to cross multiply by what my resultant is. So the y component of that force is 171 pounds. Now my x component is going to be cosine, because it's touching. It's going to be my x component over 500 pounds. Let's see, 20 cosine, that should be a big percentage, yep, times 500. X is equal to 469.8 pounds. Direction matters, so positive, positive, circle the answers, and you get that. So let's see if that matches what I told you. If I give you a 500-pound force at an angle of 20 degrees, the y is going to be positive, the x is going to be positive. If it's at 20 degrees, it's very shallow, so the x component is going to be greater than the y component. Also, x plus y is going to be greater than the hypotenuse. So all of it matches up. So, Kelly, did that help? Oh, you're welcome. Thank you for the question. So, so yeah, on the test, I'm not going to ask you to solve for x, but I am going to ask you to see who's greater than who. And if you just remember that at 45 degrees relative to each quadrant, 45 degrees from 0, 45 degrees from 90, 45 degrees from 180, 45 degrees from 270, the x and y component are tied. But if it's steeper than 45 past 0, y is greater than x. If it's steeper, I mean, if it's more than 45 past 90, x is greater than y, and vice versa, right? So it's showing you guys how to see things like greater than knowing that the x has to be greater than the y and vice versa. That's more practical knowledge, because in the real world, you won't have fancy equipment to measure it. You're just going to have to be able to see. You're going to have to see angles and ground reaction forces and weights and be able to just kind of eyeball shallow and steep and what's greater than what, and those kind of things in the real world. Um, so that's what the test is going to be about. If I give you a resultant at an angle without your calculator, you should be able to tell me things like what's greater than what, direction, and again, obviously, the sum of x plus y will always be greater than the z. The sum of a plus b will always be greater than c. Once again, that's why with Pythagorean theorem, that's why you got to square them to make it all work out. But if you don't square it, it's always going to be greater to go around than to go straight there. This will always be less than the long way. Thank you for your question. Meme hunting is a full-time job, guys. Any other questions, guys? Like I said, I do not mind clarifying or like Kelly's question all day, but if I don't want to just breathe. So so last call for questions. I'll stay as long as you guys need, but I need questions to feel sane. Ah, ooh, what a great question. So, Rodney, what a great question. So, what we have to do is we have to first define where we want to look at the torque. What I mean by that is torques on different joints are relative to those different joints. I think it would behoove us to say we're talking about the shoulder because elbow, the torque, as long as my forearm is straight, it's going to, or at least perpendicular to the bar, it's going to be insignificant. So let's talk about the shoulder. So the torque, where the force will be the furthest away perpendicularly, is going to be when your humerus is like at this position. So when you're here, it's closer. And when you're there, it gets closer. Now, one of the positive, even though the torque is the greatest here, that doesn't necessarily mean it's the hardest, or because you have other factors like momentum. Like if you're pulling yourself up, you may pass on through where the torque is the greatest. In addition, sometimes your body has it where the muscle's torque happens to be the greatest at certain positions where the external torque is the greatest. So therefore, you don't necessarily feel like it's harder. I give an example. Elbow flexors have greater torque at 90 degrees, which just so happens to be where a lot of times the greatest external force is. That's why you feel strong as an ox in this position, is because your muscles also have their greatest moment. So in terms of just sheer physics, where the external torque would be the greatest would be when the bar is perpendicular to your humerus. This would be less. This would be less. This would be the greatest in that position. Oh, you're welcome, man. Great question. Yeah, the intent of the torque lecture is just to get you guys to see how especially free weights, dumbbells, ankle cuffs, how you have this fixed weight, but you have variable moment. And meaning there's going to be certain periods where it's easier, certain periods are harder, but you have the same weight, right? So, I can hold 50 pounds in my arm, but that doesn't mean I can hold it in this position, right? So if I'm doing a lateral raise, 50 is extreme, but if I'm doing a lateral raise with 20 pounds, that 20 pounds to a lot of people seems like the exercise has a constant external force, but it doesn't, because that 20 pounds is going to be magnified, 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 magnified. And the 20 pounds times its perpendicular distance is going to be a heck of a lot greater than the 20 pounds its perpendicular distance here, and zero when it gets to, plumb bobbing with zero perpendicular distance. So that's the intent, is just to get you guys to see that just because the weight is fixed doesn't mean the effort is fixed because of changing torque, changing moment. And I think you guys need to remember, like, what's the positives of having machines, right? having machines maintain torque a moment. Let's see. Okay, so Bailey, yeah, I don't know why it's not going through, Bailey. Okay, let me read Bailey's question. How would you keep the same torque if your patient is doing bicep curls with free weights? So I'm going to give you two ways. Two ways. First is manual resistance. So if your client or patient is doing curls, and you know the torque is going to be least here and it's going to be the greatest here, then what you can do is supply, obviously you got to stabilize the arm, but supply manual resistance and then less and less and less and less push when they come up, increase push when they go down. So the first thing is supplying manual resistance when you know the torque goes down and lessening when it goes up. The second way is repositioning. So in other words, if you know that the torque is going to be the greatest here and the torque is going to be the least here, you do a few sets in the window where it's actually going to be working, and then you reposition where you now are working it in a window where the torque is going to be the greatest in the position that it was just in the least. Does that make sense? So the video lecture I gave on that is like doing cable flies, where if the cable is represented by the pin here and my torque is going to be the greatest in this position, that means the torque is going to be the least here. So I might do a few sets where the torque is going to be the greatest and then reposition myself to do some where the torque is now going to be the greatest in this position. So, so one way you could do it, manual resistance. And the second way is body repositioning. That's how you can, and remember the intent is that if you only work muscles are angle dependent. So if you only work muscles in certain windows where the torque is the greatest, then the muscle will adapt accordingly and be stronger in those positions. So to get a full range of hypertrophy or a full range of adaptation, you got to try to make that muscle work against more consistent torques or moments. Okay, so Bailey, if you can't, if it's not letting you type here, can you text me that I answered your question or that it was sufficiently answered? And let's see. Okay, you're welcome. You're welcome. Yeah. So again, the key thing here for you guys, future therapists, personal trainers, athletic trainers, is to remind ourselves that when you put on a 10-pound ankle cuff weight, that the person doing the leg extension exercise, that they're not feeling 10 pounds throughout the entire range of motion. Here, their knee extensors are feeling nothing. There is no force trying to make them flex. And as they extend, the torque gets greater and greater and greater and greater. So therefore, their muscles have to work more and more and more. So in other words, it's not a balance there. There's an imbalance. So how could you, if you know that this position, it's going to be worked the least and here's going to be worked the greatest, what could you do? Add manual resistance when it's going to be the least and then let off. And then as they go back down, push more and more and more and more. Another thing you could do is reposition. If they're laying on their back with their hips flexed, well, now this position they're working the greatest and that position they're working the least. So it's manual resistance or repositioning is the two easiest ways that you can create more consistent moment during exercise. Okay. All right, 2 good questions. Let's see if we get any more. That when you're doing the most work, I would be willing to say that the torque is the greatest when it feels the hardest. So I'll give you an example, because work is a tricky one. Work is a tricky one. So what I mean by that is, if you look at the definition of work, force over time. If I raise the dumbbell up 6 inches when the torque is very low, I've done the same amount of linear work as when I raise it another 6 inches when the torque is super high. But yet the second 6 inches is a heck of a lot harder than the first 6 inches, right? So work is maybe not a good word to use there. But the torque is the greatest when I feel it harder, right? My body knows the physics. It tells you that holding the weight out here is more difficult than holding the weight any place below it. So the external torque is going to be a function of my muscles having to play tug of war against it. So if the external torque is super high, my muscles are going to be working greater. So I guess in that regard, if we look at work as physiological work, right? Contraction intensity, then yes. But if we look at work as traditional mechanical work, then that doesn't have to be. So if your question is the torque's the greatest, your muscles will be working more. If that was the intent of your question, then yes. Then yes, your contraction will have to be greater if the external torque is greater. Yep. Now, to Rodney's question earlier, sometimes you can get a trade-off where as you change angles, your muscles can actually change their torque, not because they insert further or closer away, but you can change the angle of what they call angle of inclination of the tendon. That was the example I gave about the bicep, where at 90 degrees, that's usually where the external torque is the greatest, but that's also where your internal moment arm is the greatest. So there's kind of that trade-off there. So yes, if you meant that your muscles are working more at greater external torques, yes. Yep. Another way of looking at it is, if I had a cable, I'm going to go back to the cable example, and if I have a cable that's parallel, in other words, just trying to pull my arm out, I'm not working my pecs at all. But if I bring that cable here and it's perpendicular, it's going to be harder to hold that position, right? Well, I can hold this position all day because it's parallel. So the more perpendicular I bring it, the greater the external torque, the more work, the more physiological work my muscles have to do against it. So if that's what you meant, then yes. Great question. Thank you for the question. Another way to look at this torque stuff is with form, right? Mechanics in forms. offset linemen especially are used to their technique matters when they're trying to move people and trying to, and a lot of that is torque, trying to apply your force very accurately in order to take advantage. You know, they say a low person wins. Well, the lower person is going to not have as much torque happening on their center of mass to rotate them or to move them. And so a lot of times technique is all about application of rotational influences or torques. All right, guys. Anything else y'all want to talk about? Mallory, I thought of a different way to clarify what I was trying to say. Work is relative, right? So does that mean torque is the greatest when you're doing the most work? So we can look at what is that work being applied to? Is it being applied to the weight? The weight, that has to be mechanical work, right? Force and distance, how much does it weigh and how far is it going up, down, left, right, front, back? And then our muscles, the way we look at their work is with contraction, with physiological work. Does that mean torque is the greatest when you're doing the most muscle work? Yeah. So I thought of I think a cleaner way to answer that question. We just had to clarify what was a working. All right, guys, anything else? Because I feel kind of awkward just sitting here. Last call. All right, guys, if that's it, y'all, again, watch the lectures, look at your book. Use the lectures to clarify and develop and master the concepts in the book and vice versa. and we'll see you guys Wednesday.